Okay, so now we're going to use these tables to determine the b values for the exponential base. So what we're going to do is we are going to, if they give you a table to type in and they want you to create an equation or find a b or a value, you are going to go to stat enter. This is like the lesson that we did after geometric sequences, the green paper with the calculator steps. So I'm going to type in my x values into L1. I'm going to go ahead and write this on here, L1. And the y values are going to go into L2. Uh-oh, I didn't type these in correctly. 600, 300, 150, 75. And then afterwards, I'm going to go to Stat. I'm going to arrow over to Calculate so I can get those list of options. And then for an exponential function, I need to pick option 0. And now I'm going to arrow down to Calculate, and I'm going to hit Enter. And it tells me that my a value is 600. You always want to copy these values down in case you erase them off your screen. Your b value is 1/2. And your equation is the a value times the b value to the power of x. And they were only asking for the b value, so it's 0.5. And then if I'm wanting to see if this has growth or decay, I just look at my b value, and since 0.5, 5/10, 1/2 is not greater than 1, this graph has to be an exponential decay graph. So this is a decay factor. All right, let's go ahead and clear the calculator, and we're going to do this again for this table over here. So I'm going to go to Stat Enter, and I'm going to type in my x values into L1, did it again, and my y values into L2. And then I'm going to go to Stat, arrow over to Calc, and I'm going to press option 0 for an exponential. I'm going to arrow down to Calculate and press Enter. And then it tells me that my A is 100 and my B is 5. So I'm going to write these down on my paper. So A is 100 and B is 5, which means my equation is y equals 100 times 5 to the power of x. And they only wanted the b value, so that was 5. And that tells me that this is a growth factor because 5 is greater than 1. All right, let's look at this last word problem. So now I have the function s is equal to 285 times 1 75/100, all raised to the power of t. It models the cell phone subscribers in the small town of Centerville, where S is the number of cell phone subscribers and T is the year since 1985. First question, it asks, what is the values of S and T that are meaningful in the context of the problem in relation to the graph? Okay, that is a lot of words, and it's asking you, when you plug in a number for S or when you plug in a number for T, what are those values counting or measuring? So if I look at my equation, it's probably easier for me to figure out the variable that is being used for x because it's going to be the exponent. So in this case, t is really x in my calculator, and I need to figure out what is x counting or measuring. Well, remember for exponentials, x is always time, and it looks like time is the years since 1985. They tell me. So x, the years since 1985. All right, so now I want to figure out what S is measuring or counting. So S, if T is X, then that leaves S to be Y in the calculator. And so now I'm going to see, okay, well, what else are we counting or measuring? And I think we were counting cell phone subscribers. It actually says it here. S is the number of cell phone subscribers, right in the same sentence as T is the number of years since 1985. So, the number of cell phone subscribers. So they're counting people. Okay. So now I've told what values I can use for S. I've told what values I can use for T that I'm going to be for this problem. So now let's look at B. Find and interpret the y-intercept and the equation of the asymptote. Okay, so remember, in an equation for an exponential, it's y is equal to a times b to the power of x. Okay, a is your initial value, so if I look at my equation, which number is in the same position as a, and that would be 285. That's a. So a equals 285. So I need to interpret that y-intercept. So in 1985, there were initially 285 subscribers. You don't want to say it was the initial amount, because the next question that somebody is going to ask you is the initial amount of what? So you want to be a little bit more specific. Now that I told you it's the initial amount of subscribers, now you have a better idea of what that number is really representing and counting. Okay? All right, so now we've talked about, I'm going to go ahead and write this as the y-intercept, 0, 285, because that's where it would cross the y-axis. And then I explained it. I interpreted it in a sentence. All right, now we're going to find the equation of the asymptote. So what I'm going to do really quickly here is I'm going to sketch out a graph, and I'm just going to use the first quadrant. And remember, it's crossing the y-axis at 285. So I've got to think, if this is 1 year since 1985, and this is 2 years since 1985, and 3 years, and 4 years, and so on and so forth, 5 years, 6 years since 1985, what's happening to the number of cell phone subscribers? Well, if I look at B, my B value, it's telling me that that is bigger than 1, so this is going to be a growth. So if I start at 285 and I know that I'm growing, my graph is going to get bigger. I'm going to have more subscribers 1 year after 1985, and I'm going to have more subscribers in 1987, and I'm going to have more subscribers in 1988. And so it's going to kind of curve up and go this way, because I don't know that it's growing by the same number every year. That's why it's got a curve to it. Okay? We are not going to have 285 subscribers join every single year. We may have more, we may have less in 1 year, so it doesn't grow as much. Okay? And so it's flattening out. And again, I'm going to ignore this part on the left side of the y-axis, because if I go backwards on the x-axis, I'm going backwards or before 1985. Yes, that time existed, but it did not exist because for us, because we didn't start tracking subscribers for cell phones until the year 1985. So we don't have any data before the year 1985 to use. So now this tells me that I actually have a horizontal asymptote, and the lowest that we'll ever get is right here at 285. There's my asymptote. So now I want to find the equation for it. Well, remember, an asymptote equation, it's a Hoy line. I know it's a y equals equation, and if I'm right there where 285 is, it doesn't matter where I'm at on my x values, my y value is always going to be 285. So that's the equation of my asymptote. And now I want to answer, how many cell phone subscribers were in Centerville in 1994? So I have my equation, and I'm going to look at my number. They gave me a year, which is time, and time, that is x. Okay, so I know in my time, in my table, x and y, okay, so I know that the year 1985, that is going to match up to 0, because that's when I started counting. And then I want to get to the year 1994. So I don't want to go all the way down to 1,994. So I've got to see what number for x, if I use 0 to represent 1985, what number of x would represent 1994? So you've got 1986, 1987, 1988, 89, 90, 91, 92, 93, 94. So it takes 9 years for time to get to 1994. It is an in 1994, it has been 9 years since 1985. Well, I know that there are 285 subscribers. I just don't know how many there are 9 years later. And that's where my calculator is going to come in. I'm going to clear my memory. And I'm going to go to y equals, and I'm going to type in the equation that they gave me. So I'm going to say 285, 1.75 in parentheses, and I'm going to raise that to the power of x. And now I'm going to go to my table, and when x is 9, how many cell phone subscribers did we have? We had 43,872. So, in 1994, there were 43,872 subscribers.